Wolfram is a whole lot better. And plus, I've been using this program for Geospace. I've been using it for about 4 years now. So it's kind of old, but it does cover how you need to look at things. And as you can see, that disk is very thin. Okay. I've got a few questions that were sent, and I'm going to go over those. I'm not going all over questions. I'm going to use tomorrow, but I have 2 area questions that I want to cover, and then we'll move on to this. So here's the 2 questions of area that were sent to me. I'm not going to pull it up. I'm just going to tell you what it says. They want you to find the area, and this is a test question also, between x squared, I'm going to write that in f of x is equal to x squared minus 10, and g of x, I'll do that in blue, g of x is equal to, I done lost it, 9x. Now, of course, the first thing you're going to do is you're going to sketch it. And this one's not going to be in the first quadrant because it has a y-intercept of -10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the parent graphs tell you that it's opening upward, and it looks like a parabola. I'm exaggerating it a little bit because I want you to be able to see the area real good. So I'm making it a little bit wider than it would be. And that is, and I forgot to write it in orange or whatever color, so I'll highlight it in orange so you'll know that's f of x. The things I do for y'all. There you go. Question, gripe, complaint.
Looks cool.
It's just highlight. G of x is 9x, so that means it's crossing right here. We know a 45-degree angle is probably 1 to 1, so that means 1. 9 is going to be
something like that.
Something like that. And you see that that's why it's best to use your calculator to draw the, so you can actually see it. And if you know how to use your intersection, that's good. But here is the area that we're wanting. So now you just got to find the intersection, and that's going to be x squared minus 10 is equal to 9x. X squared minus 9x minus 10 is equal to 0. Use your reverse FOIL, x, and that's going to be, we want a -9, so I'm going to put a 1 here and a 10 here. So that means the 10 has to be negative because it's bigger, and this means unlike. Oh, I'm sorry, that's algebra. And -1 to what? 10. So -1. I told you I exaggerated. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's going to be up there. Okay, so antiderivative from -1 to 10. I'm just going to do the setup, and then y'all can do the plugging and chugging of the upper, which is 9x minus the x squared minus 10 dx. And that is the setup. Now I'm going to take it one step further. I'm going to go ahead and give you the, I'm going to write the setup with the antiderivative right below that. And I'm going to write that, where's that nasty yellow? There it is. I'm going to put it right here in this yellow. I got negative x cubed over 3 plus 9x squared over 2 plus 10x, and that's evaluated from -1 to 10. And that's the setup. Both of these are considered setups. It depends on the instructor, which one they want, either before the derivative.
Alexa, tell Xbox to pause.
I'm sorry, what?
Okay.
Sorry, talking to someone else.
Say again? I missed it.
He was talking to
Not
Alexa.
even. Yeah, sorry. Thought I was muted.
I was hoping you was talking to the group, but that's okay. All right, so there's the setup. And you can either have the setup before the antiderivative or the setup after. And I'm not going further than that because, and that's one of the questions that was sent to me. The other question that was sent to me is this one. But that was a test question, and this could be a test question. The first one, I'll do it in a dark green. F of x is equal to negative x squared plus 6x. And in orange, g of x is equal to x squared minus 4x. So there's the two graphs, and I'll go ahead and show you what the graph looks like. It's not to scale or anything. I'm just going to go ahead and the orange is going to be going like this. And I'm exaggerating a little bit on the wideness so you can see the area. And the green is going to be looking like this. And of course, I don't know where they intersect. I know 0, they do intersect. And let's set them equal to each other. We're trying to find this area right here. And that's going to be negative x squared plus 6x is equal to x squared minus 4x. And use your algebra. Add x squared minus 6x. Add x squared minus 6x. 0 is equal to 2x squared minus 10x. 0 is equal to 2x. It's going to leave x minus 5. So 0 and 5. So the antiderivative from 0 to 5 of the top, which is the green, is going to be negative x squared plus 6x minus the orange, which is x squared minus 4x dx. And that's the setup Let me look on that previous problem. I don't think I did. Yeah, I did. Okay, on the previous problem, I did finish it, and I'll show you what the answer is. I gave you the setups. There is the answer for the previous problem. So you might want to write that down. 1331 over 6. I'll leave it on there for a couple of seconds if you want to take a picture of it. And Mike could do this and put it on, take a snapshot and save it onto things I do for y'all. I'll just call it download. I'll put it up later. Okay. And this one, I'll give you the setup. The setup is negative, I'm going to draw an arrow, negative 2/3 x cubed plus 5x squared evaluated from 0 to 5. So these are the two setups. And I got 125 over 3 as the area. Now, the reason I just went over those two questions is because those are two good questions for the test. And I wanted to make sure that I cover them before I go into the disk. Okay. All right. Now, the disk question, or the disk. And I gave y'all an updated file today. I did it just in case, and I'll show it to you right quick. Let me move this over. Well, it's not moving. There we go. And I put it up on the right here. I don't know why it's doing all that blue. Must have got on something. Anyway, it's called the area and volume. I updated it today, and when you pull it up, it will have, not that, that's not it. Give me a second. It'll have these little examples down here, the disc and washer. So I added that so you can see the washer a little bit more. So I added that today, as well as going back to this guy, and I'm leaving it on there because you've got to realize that the disc and the washer, the thing that you see moving in black right there, that's what you gotta focus on. Because when you're talking about a disc, you've got two components of a disc. One is the height of the disc, and the other is the radius. Okay? So when you're talking about, I'm not going to draw a function or anything. All I'm going to draw, and it's going to suck, is there's a disc. And that disc has got to have, and that's why I suck at drawing, it's got to have a width. And of course that sucks. And the width of that disc is going to be dx. Okay? Because if you was to draw it a little bit, and I did on the other examples to where, hold on, there's your disc in a blowed up fashion without the without the width of a hair. As you remember me saying, when you apply the limit theory, you have to have the width of a hair. Well, then this right here is dx. The width that looks like a gerbil wheel. I don't know what you call it, a gerbil wheel or a guinea pig wheel. That the width of that wheel right there is exaggerated, but now it's going to look, if I can find I done lost it. There it is. Now it's going to be like that. It's going to be like paper thin. And that dx and that r, the r, and this is what you got to remember, r is going to be in terms of x, but it's also going to be in terms of f of x. Okay? This blue line right here represents the height, or the r that's changing second by second. And remember, calculus is all about second to second, second by second. Okay? So if you notice, this disc is leaving behind a trail of real thin grid lines. And that's what you're finding. That hatching right there is what you're finding, and that radius is changing. Direct relationship or direct rate is changing based on that square root of x. Now, all you have to decide is whether the disk is a disk or a hole in the disk, which would be a washer. Okay. So, with that being said, the volume of a disk, let me get this back up. The volume of a disk is equal to pi r squared h. Now, the pi is going to be, from here on out in your calculus, that pi is going to be in just about all your problems, because that is the circular motion. Your f of x is going to be your r. So I'm going to rewrite this. Volume of the disk is equal to pi parentheses squared dx. And that height is going to be, from now on, it's going to be dx. So that leaves r as your function. And they're only going to give you a function. They're only going to start out giving you one function. I think in your case, I think Mr. O'Quinn, help me out. Your question, I believe, was 4x, f of x is equal to 4x? Or was it 7x?
I can't remember.
Okay. Well, that's going to be right here. I think I have your question in here somewhere. So, if that's the case, then all you have to do is apply the limit theory and say the antiderivative from a to b of pi f of x squared dx. And that's going around the x-axis. If you're going around the x-axis. So if I give you x squared, or a function x squared, and I tell you that I want to go around the x-axis from 0 to 5, then you're going to put 0 here, 5 here. You're going to put x squared right here. and you're going to pull the pi out and do your antiderivative. So if I gave you x squared from 0 to 1, f of x is equal to x squared, and I want to find the volume from 0 to 1. Then the first thing I'm going to do is I'm going to draw it. And 0 to 1, we'll just do it real. And of course, it's going to look like that, only it's going to be a drawing like that. And of course, you see how I suck it. It's going to look like I guess a snow cone, maybe, like a snow cone, but it's with a little bit of curve in it. And that's going to be the antiderivative, the volume, is equal to the antiderivative of 0 to 1 of pi parentheses squared dx, because you're going around the x-axis, and that disc is filling up this area right here. And it's a hairline, and it's just filling it up till it gets to the center. And the smaller those hairlines, the better. And that's going to give you x squared here. So that's going to be v is equal to pi 0 to 1 x to the 4th dx. And now it's just nothing but antiderivative. Sorry. Trying to move things back around. There we go. So that's going to be v is equal to pi x to the 5th over 5 evaluated at 0 and 1. And of course, we know that the 0 is going to cancel out. So that's going to give you 1/5, and that's going to leave you with pi over 5. What kind of units?
Cubed.
That is a test question, and that is what I will test you on. How to find the volume of that function. And I'm going to pull this up again because it's a whole lot easier to see it like that rather than that sorry picture of mine. And even though this looks like a square root function, well, now I can't get it to move. Oh well. Reset. Now I'll get it. Whatever. Anyway, I was trying to get it to work. There we go. So let's do another one. X squared. Now let's do x squared plus 3. And again, it's not. I'm not trying to make them. I'm not trying to make them difficult. I'm just trying to get you to. What do you do before you walk? You crawl before you walk. And that's plus 3. All right, now what I want you to do, and we're going to go from 0 to 1. I want you to set this one up. I want you to graph it. And I want you to set it up as a disk around the x-axis. Okay, so it's going to be in the first quadrant because you know your parent graphs and you know that 0 to 1 is in the first quadrant, and you know this is a parent graph with a y-intercept of 3. 0 to 1. And it's going to be going around the x-axis. So it's going to be looking like a, I don't know, kind of like some of y'all know of some of y'all that play golf or play at golf. There's this tee that you can use. It looks something like this. That's what it's going to look like, only it's going to be on its side. It's going to look like that. Anyway, to make a long story short, you don't have to find where it's intersecting. You just set it up, and you know that this is going to be a disk because the revolution is around the x-axis. Now, if it was -2, around -2, then that would be a washer. But we're not getting there. We're not there yet. So the antiderivative volume equals antiderivative from 0 to 1 of x squared plus 3 dx. And that's going to be, and we're going to multiply, we're going to square that, and we're going to put pi in front of it. Pi comes out. 0 to 1 of x to the 4th plus 6x squared plus 9. What do we use there, people? What do we use? Go ahead and spit it out. What do we use? Nobody knows what we use there?
The shortcut.
Yes, shortcut number what? It's good that you remember the shortcut. That's a good thing. Which one is it? It's got a plus. Shortcut number 1. And where is that? That's algebra. So V is equal to pi brackets x to the 5th over 5 plus 6x cubed over 3 plus 9x evaluated at 0 and 1. That's the setup. This one is also a setup. Depends on the instructor if they want it before the antiderivative or after. Now, if you plug in, you know that 0 is, of course, it's going to go out. So 1/5 plus 1/2. 1/5 plus 1/2, or is that, I'm sorry, 6 divided by 3 is 2. Sorry. So that's going to be 1/5 plus 2 plus 9. Somebody help me out there. So that's going to be V is equal to pi times 1/5 plus 2 plus 9. And I get all together when I get it 56 pi over 5. Question on that one? Now, I think this is the question you sent me, Mr. O'Quinn. And the reason I'm including it, it's not because I like you or anything. It's because got I think there was 3 homework questions sent to me like this. So that's why I'm including it in the notes, because that way it'll knock out 3 or 4 homework questions that were sent to me. And the question is, f of x is equal to 4x and it's bounded by the x-axis, but it's revolving around the x-axis, and it goes from 0 to 2. Now, they write it in a different way, but it's basically from 0 to 2. I think they say bounded by the y and x axis, and I think they say something to the effect x is equal to 2 or something like that. In other words, but if you take out draw it, and y is equal to 4x, that's going to be a little bit sharper than a 45-degree angle. And they say that it's bounded by the y-axis, which doesn't matter because you're revolving around the x-axis. So that really doesn't help you. And the x-axis, and when they tell you that it's going around the x-axis, that's when the x-axis becomes relevant and the y-axis becomes irrelevant, because you're coming from this point. And then they say to 2, and then you drop a line at 2. So you're going to be setting up your disk going from 0 to 2, and this right here is f of x equal to 4x. So, you know, the old-timey, I don't know if y'all know what old-timey is. You know, the old-timey spin tops that used to look like this? Or a plumb bob. A plumb bob, that's what this is going to look like. It's going to look something like that, except it's not going to have a handle on it. So it's going to look like one of those old tops, or a wok. No, wok has a curve on the bottom of it. So that means you're going to be putting those hairline discs all the way up. So volume is equal to pi antiderivative from 0 to 2 of parentheses squared dx. And what goes in the parentheses? Anybody?
4x.
4x. Thank you. All right, I'm going to let y'all do it. Go ahead and take a minute and do it. Does this look like the question you sent, Mr. O'Quinn?
Yes.
Does anybody want to take a stab and tell me what the most common mistake on this problem is? Anybody want to take a guess?
Maybe not pulling out the pi.
No, they pull out the pi. That's fine. But
Squaring both terms.
that's it. Whoever said that? Did you say that, Mr. O'Quinn?
I did.
This is what students do. They go, okay, I'm going to set this up, and that's going to be pi from 0 to 2 of 4x squared. And that's what they do every single time. So it's not 4x squared, it's what? 16x squared. And that's going to be v is equal to pi bracket 16x to the third over 3, evaluated at 0 and 2. And take my red pen. Now, a lot of people say, well, Hubert, you're giving us all zeros. Well, right now I am, but if I throw a -1 in there, all you're going to do is plug in a -1 and subtract. So because this means subtract, that long line right there means subtract this one from that one. So that's going to be 16 times 8 over 3. So I'm going to go over here. And that's going to be v is equal to 128 pi over 3 cubic units. And I think there's 3 or 4 homework questions sent, and they're all, one of them's 5x, one of them's 7x, one of them's 4x. So you should be able to do that problem now. Instead of putting 4x, you put a 5x or a 7x there and do the math. Well, what the heck to do if they tell you to go around the y-axis? Well, if they tell you to go around the y-axis, you just put everything in terms of y. So if they give you f of x is equal to x squared, which is equal to y equal to x squared, and they tell you that you're going to revolve it around the y-axis, the first thing you're going to do is when you see that revolve around the y-axis, the first thing you're going to think about is solve for what? I'm sorry. Solve for x. It's the opposite. Because you got to get everything in terms of y. So in this case, and we did this when we did the inverse functions, you switched, and you solve for y, same thing, just solve for x. So that's going to be x is equal to the square root of y. And that is the function you're going to use in your formula. So what does it look like? Well, here's your function. It's still y is equal to x squared. But this time you're going around the y-axis. You're revolving around the y-axis. So that ds now is going to be looking like this. It's going to be solid, and you're going to be moving up to whatever point, and then we'll go to 0 to 1. So we're going to say this is 1, and this is going to be solid. So that's going to look like a half a grapefruit. You eat a piece of grapefruit and slice it down the middle. That's what it's going to look like. And your ds now, I'm just going to draw it right here. Your height of your disk is not going to be dx anymore. It's going to be what? dy. So now, again, my disk, my volume of my disk is going to be pi r squared h, pi r squared h. Well, pi is not going to change because that's a number. R squared is going to be basically your function of y squared. That's why you got it in terms of y. And h is going to be dy. So your antiderivative will be from 0 to 1 of pi parentheses squared dy, and plug in that square root of y. And what happens to the square and the square root? They cancel. And that's going to give you v is equal to pi 0 to 1 of y dy. And take the antiderivative, that's going to be y squared over 2, evaluated at 0 and 1, multiplied by pi, and the 0 goes out, and you're left with pi over 2 units cubed. Now here's one that's going to be a little bit different. And I'm going to go back to the drawing. And here, I can't draw it here. No, let's see. Which one am I trying to find? Here we go. Now, I don't want it around the y-axis, but this right here is going around the y-axis, but if you was to go around the x-axis, you would get a bowl shape going to the right. It would be kind of this bowl shape going to the right. Okay? Now, when you're talking about a washer, it's just like if I was talking about a distance. And a lot of you are saying, what are you talking about? If I tell you, and I'm going to be very elementary here, if you're in Anderson and you know that it's 45 miles to Spartanburg, you know that distance is 45 miles. And you know that Greenville is 30 miles. Then if I want to find the distance from Greenville to Spartanburg, I know that it's 15 miles because I take 45 minus 30. Now, I'm not trying to insult anybody's intelligence. Whenever we want to find out the difference, we subtract. So when you're talking about the washer is nothing with the washer is a disc with a hole in it. So that means that whatever's making up the disc, which is your red function, you're going to subtract the inside of the disc or the hole, which will be the blue function. So basically, when you're talking about a washer, The outside of the washer is going to be made up of like f of x. And the inside is going to be made up of g of x. So that's where you get the f of x minus g of x in the washer formula. Okay? And I don't really want you to see a formula. I want you to remember that you got to take the bigger function and subtract the smaller function. Just like you took the bigger distance and you subtracted the smaller distance. Sorry. And that's what you're going to do there. So if I give you a function like this, and I give you, and you might want to, this is a test question, it's also the basic of a washer. If I give you, let me go with blue, f of x is equal to, f of x is equal to x, and I give you a green marker, and I say g of x is equal to x squared. And I tell you that I want you to go from 0 to 1 around, revolve around the x-axis. Go ahead and set this one up. First of all, I want you to sketch it. I want you to sketch it and see what it looks like. Then I want you to set up the antiderivative around the x-axis using pi. It's hard, it's still not cloudy here, so it must be hanging up there with you.
It's over me right now.
I'll look up your hay later. My garden's loving it.
So it's pouring right now.
Oh yeah.
All my power's out in Central.
I'm close by the Anderson campus, and it's just moving in right now.
At the Anderson campus?
Close by it, yep.
Oh, it's popcorn. I'm looking at the radar right now. Oh my. It looks like it's coming. Yeah, it's kind of popping up everywhere around Anderson. I'm going to get some probably around 6 or 6:30.
Better get that baler going.
No, as long as I don't rake it, I'm fine. Hay is fine as long as you don't rake it. If you rake it, and it gets rained on, then it's pretty much nothing. All right, so I'm going to draw my handy dandy graph. And again, I know it's in the first quadrant because I'm doing 0 and 1. So here's my x. And my x squared. I'm going to exaggerate a little bit. There we go. So here is my 0, and here is my 1. So if you was to do you see a little bit of a gap here. There's a gap there, and then there is the disk. There's the disk, and you got a little gap here. And that goes around, that's going to go around, and that's going to go around, but you got a little bit of so this is a washer. So that means before we even start the problem, we're going to have to subtract something from something. So I'm going to set up my antiderivative volume equals, I know pi is going to be in there, so I might as well, because it's a revolution, so pi is going to be in there. From 0 to 1 of something squared dx, because it's around the. Now, which one is my upper? Now, if you go back to the Word document I sent you, there's one place where it just says upper minus lower. I don't know where that is.
Very top of the page.
Yeah, top minus bottom. That's for area. You should know that now because area under curve teaches you that. So I'm gonna do the same thing here, but down here, there's you know what I was trying to show you right there. Your outer one always minus your inner one. So in this case, I've got x minus x squared. Now I could break it up and I could say x squared minus x squared squared. You're going to get the same thing. You're going to get x, the v is equal to pi, and you're going to get from 0 to 1. I'm going to do it this way because there we go. There. And that's going to be x squared minus x to the 4th dx. Now, what you should be seeing here, and believe you me, I'm going to tell you right now, I love Dr. Hardin to death, but he couldn't tell you how to get out of a wet paper sack as far as directions. There are some teachers, and I hope I'm not one of them, that will lobotomize you when you're talking about a disc and a washer. The hardest part is to get it set up. That's the hardest part. And you have to rely on your picture. If you try to do these things without drawing a picture, you might as well not even do them. So V is equal to pi, and I'm just going to rewrite this, 0 to 1 of x squared minus x to the 4th dx. And now I'm going to take my derivative, and that's going to be x to the 3rd over 3 minus x to the 5th over 5, evaluated at 0 and 1 times pi. And the 0 goes out. And that's going to be pi 1/3 minus 1/5. Well, I'm going to change that to 15 and 15. 3 will go into 5. How many times? 5 times be 5x to the 3rd. 5 will go into 15, 3x to the 5th. And I'm sorry, that should have been 1. I'm sorry, I skipped a step. That should be 1 here. Or is that 5? 3 will go into
5.
Yeah, 5. Sorry, 5 minus 3.
It still worked.
Huh?
It still worked.
Okay, thank you. And that's pi. It should come down to 2 pi over 15. That's the final answer. And I don't care how many of these things you do, the hardest part is setting them up. Question, gripe, complaint. So if you was to do this one, you would have to get everything in terms of y. Okay, and they've already got it that way, so you don't have to think too much. Now I'm going to move this. Well, it won't let me. I was gonna move this. I thought you could move the axis of revolution. Yeah. If you notice, there you go, and you set it like this. Now you got a disk that opens up to a. I'm trying to get it on 0, but I'm not. Okay. Now, if you were doing it this way, you would go from 0 to, let's put this on 2. That 2 right there, 0 to 2. So if you're going to do this, then that would be, I'm drawing it. No, I don't need to draw it, but you got this, you got the, let me get the formulas, I'm sorry. You got y squared over 4, which is your blue line. Y squared over 4. And then you got your orange line, which is square root of y. All right, now set this one, excuse me, Corona. Set this one up to where you want to go from, I'm going to move this to 0. Well, that's where they intersect, 0. Try to get that on 0 too. 0 to 2. That's as close as I can get it. All right, 0 to 2. Y is equal to 0 to 2. I'll write all this down. So you could do this one as have it as a homework problem for around the y-axis with the other question. So we're going to go from 0 to 2. So volume around the y-axis, and that's going to be equal to pi. The antiderivative from 0 to 2. And here, my square root of y, or my x to, or my y to the 1/2, that's going to be, we'll put that parentheses squared minus parentheses squared dy. And that's going to be the outside is going to be the square root of y. Minus, and that's y squared over 4. All right, work on that one.
Priority 1 message coming in on secured channel.
Now that's going to be you can rewrite this and make this b sub y equals pi 0 to 2 of y minus 1/16 y to the 4th dy. Because I don't want you to sit there staring at that y to the 4th over 16 for more than a minute, because you're wasting time. You need to pull that 1/16 out front. And that's going to give you pi, and that's going to be y squared over 2 minus 1/16 times y to the 5th over 5 at 0 and 2. So that's going to give you y squared over 2 minus y to the 5th over 5 times, what does that come out to be? 80? Somebody help me out there.
It's 80.
Okay. Evaluated at 0 and 2. I'm just going to remember to bring my pi. If y'all will give me permission, I'm just going to mark my pi here, and I'll bring it down later. Okay. So that's going to be 80 right here. 2 will go into 80 40 times. That's 40 y squared. The 0 cancels out. So that's going to be 40 times 4. 2 squared is 4. That'd be 16. Would that be 1600? No, it'd be 160.
Yeah.
160 over 80 minus, I guess that's 32 over 80.
Or
32 over 80, which is equal to 128 over 80. Somebody check me. Which is equal to 64 over 40, which is equal to 32 over 20, which is equal to 16 over 10, which is equal to what? 8 over 5. Help me out.
That's right.
So I get 8 pi over 5. Somebody give me a decimal on that. What is 8 pi? 8 times 3 is 24 divided by 5. That'd be close to 5, 4 point something. What does it come out to be? Somebody got a calculator handy? Okay, I'll do it. 8 pi over 5. 8 times pi, I don't even remember where pi is on this thing. It's right there, isn't it? Equals divided by 5. I got 5.03 cubic units. The reason is we got it close. Let's see how close we are. You'll have to see it quick. I get it right up there, but I think I'm on 2. And a little bit different. I don't know if I can catch it or stop it, but you see that it gets right up there. And I can't even see if that's 2. I don't think it is. I think 2 is up here. I can't see. Let me move it.
You should be able to click and drag the
There's
Y.
2 right there. So you can see it's approaching 5. When it gets up that high, it's approaching it. So, but I'm off a little bit down here also. So, and that's a good question. You can see, and the main thing is setting them up. If you can set them up, you can do I mean, if you think about it, the algebra, there's 80% algebra. Well, I'll back up. 60 to 70% algebra, 10 to 15% calculus, and 10 to 15% basic math. So, you know, the calculus is still minimal. Okay, y'all feel good about disc and washers now? Nobody's gonna say anything.
Pretty good.
Pretty good? Okay. All right, well, I'm going to cut her off, and tomorrow we'll go over questions. Questions on everything. So if you want to, I need for you, some of you, that if you need to wait until after class, just like my 120 did today, some of them plan to stay after. So if you want to stay after, you're welcome to stay after. I'll stay after tomorrow until we get all these questions done. Okay? Let me go ahead and shut off the presentation and shut off the recording.